Hey guys, today we're gonna solve the range of sum of BST, which is binary search tree, problem 938 of Leetcode. It's an easy one. Basically, this problem, okay, it's an interesting one, especially if you're starting in binary search tree, where we have a binary tree, and we have a low value and a high value. And basically, we need to return the sum of values of all nodes with a value in the range. So say we have this one, this binary tree with 10, 5, 3, 5, 7, 15, 18, and nil here. And we have two values for low and high, 7 and 15. So basically, all the values that are between 7 and 15, say 10, 7, 15, those we sum them and we give back the output, which is basically 32. 10 plus 15, 25, plus 7, 32. So how are we going to do that? Well, the example 2 is the same. We have another binary tree and we are trying to basically get the values between the low and high and sum them. Okay, so there are, I would say, two ways maybe. The first one is to create a, I would say, a temporary variable, an integer, as we're going to return an integer, and where we're going to test first if the root, is nil. If it's nil, we return 0, and if it's not nil, we're going to basically check the value, the root value for each node, and see if it's between the low and high. If it's between the low and high, we're going to basically add it to the initial variable that we created, this integer, let's call it sum, and basically we're gonna then use recursion. Why recursion? Because we are traversing a binary search tree, and basically we're gonna call again and again the function, going to the left and right depending on the values, and getting each time this sum number. Now what we're going to do in the case where the value is not comprised between the low and high integers, well, this is what I'm saying. We just continue and we use recursion to get the next values. Okay, so how are we going to write this? So I'm writing in golang. So we're going to create a sum variable. And the first condition is we are gonna say if root is nil, then we return obviously 0. Okay, and then we're gonna check for the node if the value of this root is superior or equal to low, and the value of this root, or I would say, well, and when I say or, I mean it's either higher than low and lower than high, so it's between low and high. So yeah, and if it's lower than high, lower or equal obviously, then what do we return? We say that sum is a sum plus the root.val, and also now we have traversed, or only the root node, right? So say we could start at 10, so we are at 10. And yeah, okay, we got this one. 10 is between 7 and 15. It's beautiful, but we also need the 5 and 15, right? So what do? Well, we call again the function range sum BST, and we call it on the what? The left and the right. Obviously, we want to go there, and we also want to go there. It's a binary tree, so we have two values, left and right, right? So we're gonna go how did I define the struct? Yeah. Root left and low high, it's the same numbers, and we're also gonna go to the right, so we're gonna call root.right and low high. Okay, so that's good, but is this enough? Definitely not. This is not enough. Why is this not enough? Because right now we are in the condition that the root val is basically between the low and high. So if it's not in the low and high, well, it's not gonna work. So let's add this condition. So if we say that root.val is strictly inferior to low, or we don't need an end here, or root.val is strictly superior to high, then what do? Well, in this case, we don't append anything, I mean, to sum. I mean, we don't add anything because, well, it's not verifying the condition of being between low and high. So we directly return the function, the sum of the range, sum BST to the left and to the right. So let me give you an example. So we started with a 10, right? So 10 is good, we put it to sum, so now the sum is basically 10, right? And then we said that we go through range sum BST, and we go left one, and then we go to the right one. So if we go to the left one, we go to 5. So here 5, you can see that it's definitely strictly inferior to low, right? We have 7, 5 is not 7. We all agree on this, I guess. So what do we do in this case? Well, we don't need to take it into account, so we don't touch the sum, but we still need to call the function again, the left and right. So if we call the left, guess I'm gonna copy paste instead of writing down everything again. Yep, that's it. So in this case, this is not bad. And now you're gonna see, if we go back to 5, we go to the left where it's 3, and if we go to the right one, it's 7, and 7 is not too bad, right? So in 7, we're gonna call range sum BST, and we're gonna enter this condition, and we're gonna append 7 to sum, and when we return the sum, this is gonna be beautiful, and it's gonna work. So this one, I would say, is a not naive approach, but it's the approach that doesn't take into account the properties of a binary tree. Okay, so this one is good, but let's have a better one. So the better one, what is the better one? Basically, the condition here of a binary tree is that when you go to a node, if you go to the left of the node, say 5, this value, the left one, will always be lower than the parent value. And same for the right one, and it's actually the opposite. The right one will be higher. Okay, so if you take a look at the example one, 10, you go to the left, 5 is lower than 10, and then you go again to the left, and 3 is lower than 5, but 7 is higher than 5, right? And 10, you go to the right, is 15, you go to the, well, left is nil, but you go to the right, is again higher, it's 18. Take the second example, you go to 10, you start with 5, you go to 3 to 1, so each next node is lower than the previous one, and each right node is higher than the previous one. So we go to 5, if we go to the right, it's 7 is higher than 5, and then we go to the left, and 6 is lower than 7. And same goes with the right one. So how we take into account this property of the binary search tree? Okay, so let's remove all those stuff. Well, maybe we don't need to remove the first condition. So let's remove some. We don't care anymore about this one. So we have the first. Okay, well, okay, it's good now. So we have the first condition where if the root is nil, we return 0, right? Then we're gonna say if the root val is strictly superior to high, what's gonna happen? Let's think about it. So in this second example, we're gonna take the second example. We have low 6 and high 10, right? So if we go to the right, so for example, 10 is good, so it's between 6 and 10. But if we go to the right one, so this 10, we have 15, and 15 verifies this condition. Root.val is strictly higher than high. Strictly higher, than high, obviously, which is 10. 15 is strictly higher than 10. And we know the property of a binary search tree that the right value is going to be higher than the parent one, right? So 18 is going to be higher than 15. So it makes no sense, actually, to verify if this value is higher than high, because we know by the property of the binary search tree is going to be higher. So we skip it and we go to the left one, because why the left one? The left one is lower. And as it is lower, it could be lower, for example, by 2 in this example, but also could be lower than 5. And in this case, we're gonna basically verify the condition. So we need to test it, right? So in the case it is higher, we don't go anymore to the right one, we skip it, but we go to the left one because we want to see if it's the lower value is still inside the low and high basic conditions. Okay, so we return. What do we return? Again, we're gonna use obviously recursion. We're gonna return the root dot left, low, high. Okay, so now with this in mind, obviously we're gonna do the opposite with the low one. So what are we gonna write? If we have the value of root that is strictly inferior to low, say 5, here it's lower than 6, does it make any sense to go to the left again and have a lower value? 3, 1. Yes, we could do it, but it makes no sense because we know, again, with the property of a binary search tree, that this value will be, again, lower than the value. So it's not going to respect the condition. It's impossible. So as we did with the value, with the previous condition, in this case, we're going to return basically the root dot right. Why the right one? Because the right one can be, well, will be higher than the root dot val. And it could, technically speaking, verify the conditions and be higher than low, equal to low, or equal to high. It's all those are possibilities, so we need to test it. Okay, and if we don't have any of those conditions, we are basically in good hands. Let's put it this way, and we're gonna just return as we did in the first solution. We're gonna return basically the value, root right, and the sum also, and we add this range sum BST root dot left, low, high, and we should be pretty good with this one. So let's submit it and see how it goes. There we go. So this is working fine, and yeah, perfect. If you have any questions, please leave comments and I will try to reply to them. That's it for today. Have a nice one, guys, and talk to you later. Ciao, ciao.